Hello 108 students, Mr. McHugh here with you. I'm going to continue working on chapter 2.1 and we are going to take care of page 2 here on this video. Okay, now I'm looking at example number 2 here, and what's different between this problem and the last one? I'm noticing parentheses, and from please excuse my dear Aunt Sally, the P tells you parentheses is the highest order of operation. We must always deal with those. Okay, so you want to think of unwrapping the fruit that I use that example for the distributive property, and so between the 2 and the parentheses, you know there's an assumed operation of multiplication. Okay, that's just because mathematicians did not want to put the little dot every time. So turn around there. First thing I do is you want to get rid of or clear out the parentheses. So do the distributive property. 2 times x is 2x. 2 times negative 5 is negative 10, and I brought everything else down. And that is what I did here on my very first step. Nothing wrong taking the first step, clear out something. Now look at the problem. What can I do to make it easier? What can I combine? And CLT is my combined like terms, and remember it's not bacon, lettuce, and tomato. Okay, it's not that. Now 2x plus 3x class combine together to 5x. Bring down the negative 10x. Here's your equal sign. Now I'm a little guilty here. I would recommend you keep those equal signs going in a straight line when you do your homework, when you're doing them. Much easier to follow your flow. Okay. Now with that said, I brought down the x plus 6. I left it there. Look, I popped up the 1. Am I allowed to pop up a coefficient of 1 in front of any variable? The answer is yes, because 1 times anything is itself. So I only put that up there to illustrate the key concept here now of combining like terms. When the x is on the right side and the left side, I always recommend move the smaller one. The reason I say that is because it usually makes life easier dealing with minus signs. You get fewer of them when you move the smaller one. So opposite of plus 1x, minus 1x. Do it on both sides. Maintain balance. Subtraction property of equality. Okay. Add your columns up. 5x minus 1x, 4x. Bring down to negative 10x. Bring down what? The 6, because what's this add up to? 0. Okay, now look at your problem. Is it getting easier? Are you kind of working down the funnel like we've talked about? I believe we are. Okay, now I look at the problem. I also recommend, if you have a sheet of paper, cover up the work that you did beforehand, so you just focus on this step right here. That helps a lot of students out. Okay, what can we do to isolate the 4x term? Look on the same side. Here's your equal sign. You got a minus 10. You got to take the opposite of minus 10, which is plus 10. Add it to both sides. Okay, that's in effect moving negative 10 over, but you take the opposite. Okay, so when we do that, add them up. What's negative 10 plus 10? There's the 0. Most of you won't put it in there. Don't need it. So now you've got 4x equals 6 plus 10 is 16. Now your closing move is to what? Take the coefficient in front of the x. So we do this almost every time. The last step of solving the algebra equations. Thus, that's why I call it the closer. Divide by the coefficient. 4 divided by 4 is what? 1x. 16 divided by 4 is 4. Answer: x equals 4. And you're on your way. Okay, very good. Now, let's get into something a little more challenging. Example 3, it says fractions. Determine the LCD and multiply. Okay, this original problem does not have the parentheses, so bear with me. I'll try to highlight it. It's x plus 7 divided by 6. Then it's 2x minus 8 divided by 2 equals negative 4. That's the original problem. Okay, now you look at these and they look like bears, and what the key to doing this problem is to look at this key and say, I have got fractions. I would like to get rid of them. Don't care for them, would like to make life easier. Okay, now this is all a term up here, so look at the LCD. 6 and a 2. What's the smallest number that both 6 and 2 go into? Class, answer 6, right? Okay, that's the LCD. Now once you figure that out, you're going to multiply by every term across the equation. X plus 7 parentheses 6 is a term. That's why I put the parentheses around it. I'm multiplying by the LCD. Look at the second term, 2x minus 8 divided by 2. Going to multiply it by 6. It must maintain balance across the whole equation. Multiply the third term, which is the right hand side, by 6. Okay, does everybody see the 6 being multiplied across the equation? Okay, when you do that, it, quote, clears out the fraction, because what's the beauty? Look at 6 in the numerator, 6 in the denominator. What happens? 6 divided by 6 is 1. What are you left with? 1x plus 7. Over here, 6 divided by 2 is 3 times the parentheses, 2x minus 8. Okay? Look over here. Negative 4 times 6, negative 24. Here's your new equation. In one step, you got rid of the fractions, and now you're dealing with something manageable that you've had before. In fact, it's now the same process that we did up in a step above. Now, take your time. Learn to do your reads. Learn to look at your flow of your isolating your variable. What do you see first that you need to deal with? Answer? Hopefully you said parentheses. Use the distributive property. Talk yourself through these problems. Know what property or what step or what tool you're getting out of your toolbox that you're using to simplify the equation line by line. Okay, so here we go. Distributive property. 3 times 2, 6x. 3 times negative 8, minus 24. That's all I did. I brought everything else down. Now I'm looking at this problem. Cover up the step before. Can I combine like terms on the same side of the equations? Yes. And look at this. If you don't see an x, if you don't see a number in front of the x, what's the coefficient? 1. Don't forget it. 1 plus 6, 7x. Negative 7 minus 24 results in negative 17 equals negative 24. Okay. Now these are getting easier and easier. You got 7x happens to be the only variable term. It's on the left-hand side. What should I do with minus 17? Add the opposite, because it will maintain balance by the addition property of equality. I add 17 to both sides. What do I get? Here's my 7x, and this adds up to a 0, and negative 24 plus 17 is negative 7. Okay, we're almost there. What's our closer step? It's the same thing. Take the coefficient in front of the variable, divide by 7 on both sides. 7 divided by 7 is 1x. Watch your signs. Negative 7 divided by a positive 7 is a negative what, class? 1. And you got it. Okay, we're doing great. We've got one more example here. This is the case of there are decimals. We're going to do these in mixture problems here in a little bit. And so in the old days, they used to make you take all these, multiply them out, and keep all these decimals, and then finally mathematicians got a little smarter and said, you know what, if I multiplied by 10 or 100 or 1,000, whatever it took if I wanted to move the decimal so I had whole numbers going across, then life would be a whole lot easier. So that's what you want to think about. If you see decimals in a problem, think of what can you multiply by. It's either 10, 100, or 1,000 in most cases. To figure that out, count how many places you're going. So I need to move it I need to move it 2 places. 2 places. 2 places. 2 places is what? Tenths, hundredths. So if I multiply by 100, then that's going to clear out the decimal. So 100 times 0.06 results in 6. 100 times 0.09 results in 9. 100 times 0.07 is times 15 is 105. Okay, now notation here, let me back up I put a big bracket here across the whole equation and I multiplied it by 100. I was trying to get you to do the distributive property, and that's the step I just described to you. Multiply them all out. Now you've got a fairly manageable problem with decimals gone. Okay, now I didn't work this out here in this example here. What would be next? I think maybe we could do this real quick here. We got what? 6x plus what? 135 minus 9x equals 105. Okay, how about 6x minus 9x? That would combine to be what? Minus 3x plus 135 equals 105. So I need a minus 135 on both sides. I'm running out of room. And you guys are probably going to be able to figure this out. Minus 3x equals what? What? 15? If I'm doing it right, I think I am. Yeah. And so last step, divide by what? Negative 3. to isolate the variable, and I got x equals 5. Okay, class, that's going to do it here. We finished page 2, so I will see you for page 3 in just a minute.